Hey everybody, welcome back to the 74th episode of Taps and Patience. I am AJ with Audacity Micro and here with Harrison of Precision Ingenuity. I normally get to say something a little bit at least fun or witty in there, but I lost all of it in the middle of that intro, so I apologize for that.
No worries. It's kind of I don't know about you, but I'm just kind of tired today because of the time change. It's kind of thrown everything off. So, how you been?
So how you doing? Oh, I've been on vacation.
Oh, lucky you. That's why we didn't meet last week.
Yep. So I'm kind of getting back in the swing of things. I did make some parts the last couple of days, some of those fidget cubes. I'm getting pretty close to done with them.
Nice.
But I screwed up a batch like way back when I was working on them like a month ago. This is why I didn't finish them. I screwed up a batch. I think I lost like 24 of them. And so I was like, oh, I need to figure out what went wrong with those. And so I stopped working on it and I just never got back to them. And I figured out what went wrong. It was actually, of all things, revision control on one of my files. Yeah. So what happened is at one point my computer crashed when or the battery died or something, or Fusion crashed probably when I was doing them. And it didn't save the changes I made to the file. And basically the cubes ended up in the wrong spot. And I ran 24 of them before realizing what happened. And it, like I said, it just took me a while to get back up and running. And so I finished all of the ones except for those 24. And then I went to run them again today. And I screwed up like the first 20 of them before realizing it because I'm dumb. So I just wasn't measuring the thickness of them. And so, which is like the one critical dimension. And so I had to remake another like 20 of them, but...
Oh, man. That's annoying.
Yep. Pause 1 second. So I'm working on that last batch. They are... Well, I basically just have one op of those done at this point, but I should be able to knock out all the rest of them pretty easily tomorrow. And then I just need to do the coin stands, and I can finally get rid of that Kickstarter that's been hanging over my head forever.
That'll be good. So, you need to get that thing done.
I do. There's a couple things I just need to get done and out from hanging over my head. The next thing is redesigning the fixture for the carabiners. Because I've been not making carabiners for Scott, and he really needs them, and I'm kind of costing him a lot of money, and I'm sorry, Scott.
Yeah.
But I'm just so tired of my process that is like 95% reliable. And I need to get that last, 49 or 4.99999%.
Gotcha. So. Understandable. I'm in the process of working through some process improvements as well. So I've been trying to dial in this 5-axis with the MRZP, and needless to say, I've been bashing my head against the wall quite a bit, trying to get it figured out.
So I, of course, know exactly what an MRZP is, but could you describe it for those who don't know?
Yeah. Machine 0 point control. And so basically what it is that you define where the center of rotation is in the A-axis and the C-axis. And then once you've defined both of those, and they are where they should be, in theory, you can put any part on the 5-axis rotary, and you can probe it, and the machine will look at what you've probed and compare it to the MRZP, and you can rotate and move things around to where they don't have to be exactly lined up on the center of rotation for 5-axis work. And so it can be a really nice, convenient feature to have. And if it's off at all, you make bad parts. So that's what I'm fighting with right now. And basically, to kind of make a long story somewhat short as possible, when Haas installed the machine... Okay, so I've learned a lot of information, even just today. And so, for starters, When Haas installed my machine, I did not realize this. They are not obligated to install the Trunnion. In fact, I talking to some of the Haas techs of my local HFO, they actively don't install them because if they install them and then someone crashes a machine, they have been blamed in the past for that, and so it's a liability thing. And so I was able to convince the Haas tech to install mine
Mhm.
because it was our first one. And so I was really glad they did that. But apparently, at least our local one, they don't do that normally. So that was one thing I learned.
Sounds like a lot of excuses to me.
It does, but I understand it. So, like, as someone who could be on that other side of the fence, like as someone who could who could see it, wear someone else's shoes, or walk a mile in someone else's shoes, I can understand why they wouldn't want to do it. You know, if Haas is not requiring them to do that as an HFO, and if doing so can bring on liabilities of lawsuits or something else from a customer because they think you did it wrong, then yeah, I totally understand why they don't want to do that.
I still
So
think it's the lazy way to fix the problem. The right way to fix this problem is to print out inspection report showing that the thing is dialed in when they left it. And if they
yes,
come and run the same test again and it's not dialed in, they have the paperwork to say it wasn't us.
exactly.
That's the
Oh,
right way to fix this problem.
100% agree. But whenever we were going through this process and we thought the probe was the issue, our local HFO or our local Haas tech that was there, he reached out to Haas in California, the main factory, and told them that, hey, we have a defective probe, and they said, oh, it wasn't defective. You guys broke it. You got to pay for it. So like, it was coming out of the local HFO's pocket, even though it was a brand new probe, if it was in fact broken. And so
Yeah.
they wanted to make sure it wasn't broken. The HFO was going to order one to replace it if that was the case. But just the factory's mentality of it, I understand that if you know if your local HFO does not have the backing of the main parent company, I can understand why they don't want to step out on a limb if they don't have to.
Oh yeah, I don't blame the HFOs. I blame Haas. Like,
Yes, yes, exactly, and that's where that's where I would place the blame as well. So, anyways, regardless of all that, because I got them to install the TRT onto or the Trunnion onto our onto our machine, I caught a glimpse of a program that one of the Haas techs had wrote to help dial in MRZP, and I've been hunting for this program ever since. And I talked to a whole bunch of other people online, and basically they just everyone that I talked to said make a cube and cut it and then dial it in that way. And I've I've made 4 or 5 of those cubes, and I have spent 2.5 days machining those cubes and trying to dial everything
oh
in.
gosh.
And while I was making progress, it was one step forwards, 2 step backwards type progress.
Yep.
And eventually, I got a hold of the Haas tech who actually wrote it. He's actually a Haas application engineer for my local HFO,
Mhm.
and I would offer this software to anyone who reaches out because I know people are going to ask for it, but it's not my software. But anyways, I got it from him. He gave me a copy. Otherwise, I would freely share it if I knew he was okay with it. But basically, what it does is you put a little ball, like one of those precision ground balls, on a stand on your machine. You probe it in, and then you can tell the program to rotate it to any position and reprobe that ball, and it'll tell you how far out it is at that position. And so you can start at 0, and then you can rotate your C. In my case, it's a C to 90, to -90, and to 180, and you can see what it measures in all those positions, and you get your C axis dialed in, and then you can rotate it up on its side, and then you can dial in your A axis, and you can rotate it in different positions. And in that process, I found out that my Trunnion was about 5 thou out in the 5 thou out in how it was sitting on the table. Like
Yeah.
the A
It's
axis,
tram or whatever.
yeah, the tram between the A axis and the X axis. They were not in line with each other.
Are there any like
And
precision surfaces on there to help you get that alignment?
no, no, there's not. So the way you
Okay.
get an alignment is you have to rotate the platter down to where it's parallel in the X and Y axis. And so you run a tenths indicator over it and make sure that it's perfectly level in both X and Y. And then once you've done that, you rotate it up to 90 and you sweep across the face of it and you make sure that it's perfectly flat there.
Okay, that makes
And,
sense.
and then that makes sure that it's parallel or trammed into the axis. And so what I think happened is I think the Haas Tech guy, I think he set it up properly. Like the second or third part that I was running with it, I had a 3/8 inch tool that I was running on a really, actually, I was doing a calibration cube. This was a calibration cube. Although it was before this week, it was my first attempts at dialing in MRZP. During my first attempts, I ended up having a piece of material. It was sticking out really long, and I laid it down on B90 or A90, and I had a tool that came around the top of it. And when it came around the top, the part was long enough that it had some flex in it, and it
Mhm.
basically drove itself into the part and ended up breaking my tool and pulling my part out of the vise a little bit. And I think that's what caused the A axis to lose its tram to the X axis.
Possible.
And I didn't know that had happened. And even when I was doing the cube, there were certain measurements that I just could not get to not be aligned. And no matter what I changed. And after I got my hands on this program, it was like hitting the easy button. I was able to dial everything in like in a fraction of the time without cutting anything. And I was able to find out. I called the guy and I was like, hey, there's one measurement that is not changing. And he's like, oh, if that measurement's out, he said that measurement should be dead nuts. And that if it's not dead nuts, it means that you're off in your A axis
Okay.
and in your tram. And I was like, oh, that makes perfect sense. And so I ended up having to redo it. And I've gotten it much better, but it's still not perfect. So I'm gonna have to work on the tram tomorrow some more. Long story short, I've spent over 3 days on this now, and I did more in the last 4 hours of today than I did in the cutting cubes the all the time before that. So
Yeah, it's amazing what having the right tools will do for you.
yeah, and there were so many people that I talked to that just didn't think that something like that exists.
Huh.
And so I know after I say this on the podcast that I'm going to have a lot of people probably blow me up about this, but let me tell you something. I bet I could get MRZP dialed in without cutting a single chip and in under 30 minutes with that program. And honestly, you could get it done in less time if I wasn't so persnickety about having everything being dialed in.
Yeah.
Because Haas claims a plus or minus 2 thou in any position, and using that program and rotating to different positions, if you dial it all in with the ball in one position, it will be plus or minus 2 or plus or minus 1.5 thou. But you can actually rotate the platter into different positions and keep reprobing it in multiple areas, and you can distribute that error because the error will all be on one side. Like if you look at an error bar, if you probe it in one position, it's like your 0 point is that position and the error only goes in one way.
Yeah.
You can shift that error bar into the middle, and then you can be less than 1 thou. You could be, in fact, in one of the axes, I got it down to 3/10 of plus or minus 3/10 in any position. But I'm that measurement's gonna go right out the window because I still have to so I got my C platter within 3/10,
Mhm.
but because I'm still not good on my tram, I'm gonna have to redo C
Yeah.
after I retram X again. So, anyways,
So are you saying that like from like Haas is advertising that as not being more accurate than plus or minus 2 thou? Like don't put a part that's plus or minus 2 or tighter than plus or minus 2 on it?
I honestly don't know. I've never looked up the specs on the TRT, and I couldn't find any from the little bit of digging around I've done. The 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 guy who wrote this program, he also created a Word document based on his own internal testing and said, if you see any value, he said all these machines should be able to do better than 2 thou. If you see greater
Huh.
than 2 thou, then something's off in the machine. So this is, I think, an internal service document that our local HFO has for themselves. I have no idea what Haas actually themselves, like, I've never actually looked to go, like, they give it in like arc seconds, like
That makes
they're,
sense. Because that'd be the resolution of their
yes,
rotaries, but
but I've never converted that to like a how many thou, you know, on a part of whatever size. Because it'll grow as you get a bigger part. Like if you're holding like a 14
yes.
inch part or something, like it'll be bigger. And so this is just what their internal document that they wrote the program and then they wrote the document and they give it to their techs whenever they go to dial these things in. Because you can have our local HFO come in and they have a tramming surface, but you have to pay every
Yeah.
single time they come out and do it. And so I'm trying to avoid that. So, and I want to know how to do this on my own anyways. I want to know for my own education how to do it. So,
When you first bought this machine, you were talking about taking the rotary on and off the table. Are you ever going to take this thing off the table now that you've been through this?
honestly, it's less daunting now that I have been through it. Now that I know what I'm
Okay,
doing,
that's fair.
this is actually making it easier. Like having this software and getting proficient at it. I was talking to the guy, and he said that one of his local shops, he says they take the rotary on and off, and they said they can have it up and they can take it off and or they can go from it being off the table to on and ready to run parts in under an hour. And he said usually they can do it better than 30 minutes. And so that sounds totally reasonable. Like once you know what you're doing, like this is honestly giving me more confidence to be able to take it on and off with ease. So,
I guess I'm just more impatient because I'm like, oh gosh, half an hour, that's so long. But
well,
that may just be for my attention span.
yeah, yeah. I definitely would say I can see why someone, if you didn't have the right tools to do this, I wouldn't want to touch it. Like if I was doing this cube thing, I would never want to touch it.
Yeah.
Like if that was my only way to dial it in, I would put it on and I would never want to take it off ever again. But now that I have this program and I can dial everything in, it's like the easy button. You run the probe, it spits out a number and says, "Hey, you're out by this much in this axis." You go and change it by about that much, and then it'll be a couple tenths off from there. And it is so easy compared to what I was doing before. Like, yeah, it's insane. So, anyways, I wanted to go kiss the guy after I got this program. I was at the end of my rope. I was at a bad place trying to cut all these cubes. Um. Anyways, so I've had a long week, and it ended on a bright note. So, except for the fact that I got to retram it tomorrow,
And
but
do everything again.
do everything again. But
Yeah.
it should go much faster now. So
So we're both making cubes.
yeah, yeah. Mine's yeah. I can't sell mine, although I'm gonna have enough to.
Yeah. I mean, I sold mine like 6 months ago, so it's
Yeah.
basically the same.
So apart from that, we've been getting really busy. I guess the word of our 5 axis has finally kicked in, and I've gotten like, oh, I don't know, like 5 to 10 RFQs in the last week, and like over half of those have turned into POs. So Yeah, we're pretty
Okay.
busy.
Yeah. Sorry. Brain catching up there. Well, that's
So
good.
so, but a lot of that depends on this 5-axis Trunnion producing good parts. So
Yeah. So is it 5-axis work or 3-axis work?
it's 3-axis work, but you hear the what's the phrase I'm thinking of, like when you get a hammer, everything starts to look like a nail or
Yeah.
something. And so like
When you get a newer, shinier hammer.
yeah,
Yeah.
yeah. So like all of these parts that I'm looking at, they are technically parts that I could run on 3-axis work, but man, when you got that 5-axis and you can just hit the easy button and just go, it's all I want to do now. Like I don't want to do any vice work at all. I just want to do 5
Yeah.
axis work. I'm hooked. It is insanely easy, and it's yeah. I will always have 5 axis going forward. This is the new normal. I might trade in my Haas for Hermley or something, but
Ooh.
I don't know when that would happen. But no,
I
this
bet
is.
they'll calibrate their trunnion for you.
I bet they would too. I bet they would bend over backwards to help us out. So if Dylan has anything to say about any of that,
Yeah.
because I think he's been treated very well.
Yep.
But no, it makes sense. They're it's amazing how much I've learned in such a short period of time dealing with 5-axis. I am by no means an expert in any of this, and I am still a like very new to all of this. But wow, I feel like I've shot up the ladder in terms of like exposure, I guess would be the best way to describe it at this point. And it is a whole different world from where I'm at right now, and I am ready to scale more mountains after I get this thing dialed.
So, knowing what you know now, would you have stayed with this machine or gone with like a UMC 500?
I don't know. I don't know.
Okay. Maybe next question then. Next machine, if you had to choose between buying another VF3 with a trunnion or a UMC 500, which would you buy next?
Hmm. See, I just got done talking to another guy on Instagram who has a UMC 500 and a UMC 1100 or a UMC 1000, and he seems to think that I will actually be able to get tighter tolerances out of my Trunnion than he does out of his UMC.
Interesting.
And so, because I told him, plus like I should be able to do better than plus or minus 2 thou, and I think I could do better than I could do plus or minus 1 thou. And he said that he's about plus or minus 3 or 4 thou
Huh.
with his 500.
Maybe he
So
needs your nifty program.
maybe, which, yeah. So I don't know. I definitely would probably, if I'm going to get a more serious machine, I probably would skip Haas altogether. But at the same
Yeah.
time, I don't know if I would go like Doosan, because I feel like I'm going to be in the same problem. Like I would need, like, for one thing, while I don't do a lot of simultaneous 5-axis, the Deber toolpath from Fusion is basically a simultaneous 5-axis code generator. And
Yeah.
so I don't know if you can. I would love to hear from anyone who has a Trunnion on a Doosan if they can run that toolpath.
Oh, because they're Fanic, right?
Yeah, they're Fanic, so you can only do 4+1. And so I would be curious if you can, because whenever I run it on my machine, it's full simultaneous. All axes are moving and twisting and doing all kinds of. Or maybe there's a way you can constrain it in Fusion, and I just haven't figured it out yet.
Well, you can use it in 3-axis, so I'm sure.
Yeah, you can use it in 3-axis. And maybe that's what you have to do, is you have to just create multiple 3-axis programs instead of a single 5-axis program. Maybe that's
Yeah.
what it is.
That's interesting. I know. I mean, Fanic can do 5-axis. You just have to pay more. It's just
Yes. Yeah.
the cost to go from 3+2 to 5-axis is more than on something like a Haas.
Yeah. Yeah. And so I think at that point, if you're looking at Doosan, or something better than a Haas. A brand I haven't really considered would be like DMG.
Mm-hmm.
And honestly, as like the reason Haas is so popular, or the reason I like the Haas and the reason we went with the Haas was purely a cost problem. It was right at every single time we've gotten a new machine, it's been right at the limit of what we could afford, and this machine is no different. It would be great to fantasize about having a better machine than this one, but we're still going from a Tormach to a VF-3 SSYT, which is
Yeah.
a huge jump. And
You're not going from a Tormach to a Kern?
yeah, and so
What?
and so this will get us by for a long time, but it's definitely not the end all machine. And I
Yeah.
never claimed it would be. I did claim that it was better than people give it credit for, which I still stand by. But I'm definitely seeing more and more of the limitation side of it. Not that I'm making excuses for the Haas, but I definitely it's definitely a good reality check on what other machines should be capable of. And I don't have this thing dialed in yet. I'm sure once I get it dialed in, I'll get much better than I have been. That's a learning curve on my part.
And you know what? The reality of this is you're going to get it, like, once you get comfortable with it, once you get it dialed in, you're going to start making parts, and
Yeah.
you are going to make parts that are just as good as coming off of a Mori, and you're going to make more money because your machine payment's lower.
Yeah.
Now, maybe you're not taking the parts that have a plus or minus 5/10 positional tolerance, but like
Yeah.
that doesn't seem to be a lot of the work you do anyway. And like you would make more money on the VF3 than on the Mori because the
Ye-
payments would be lower.
yes. Yes. And I would love to get into that positional type work because I'd like to get into ITAR and I'd like to get into some of those crazy geometry parts that have all that stuff. But managing my expectations of what this machine is comfortable doing is a big deal. And so, like you said, most of my parts, I don't need that kind of accuracy, but I want it. So,
Yeah.
like, it's going to happen at some point. And I think this machine is infinitely more capable than I've seen it be so far, just because it hasn't been set up right. Like, all of my issues are setup issues. I haven't actually seen what the machine is actually capable of yet.
Yep.
Like, if I get everything dialed in and it's running true and I'm still having problems, then at that point I can attribute that to tool deflection, part deflection, or just general Haas limitations. The fact that I was able to get my C axis within 3/10 repeatability, and that doesn't account for my tram, makes me think that I should be able to get at least a thou or better
Yep.
on all the parts that I'm running. And if I got that, that would be plenty good for 99.999% of all the parts I do. And if I do need that tight of tolerance, I can put it in the 3 jaws, because outside of the 5 axis, it's still, probably a 2 to 3/10, hold all day or type of machine, plus or minus.
You can
So,
also probe in a specific side of a workpiece right before you machine on it.
yeah, yeah.
So,
And so this machine's still going to be an awesome addition to the shop. And going through this process, as stressful and as many hours of sleep as I've lost on it so far, at the end of the day, I'm a lot more confident now than I was before. So, anyways, that's basically been consuming me the last 3 or 4 days. I don't even know what I did before this.
yeah. I feel like I was just kind of negative there on Haas. I will say I have been thrilled with my little office mill. And like, yeah, you got to kind of learn some of the limitations of the, 40K RPM ISO 20 spindle
Mm-hmm.
that are probably true to just about all spindles of that type. But man, I ran some plastic parts the other day, and I think the very first part came out to like 2/10 under, and the
Mm-hmm.
last part came out to like 3/10 under sized.
Yeah.
It that everybody. So I had a video that did really well where I made the teeny tiny parts, and everybody was
Mm-hmm.
like, "Wow, you can't make parts that small in the Haas." And it's like, well, I did, and it really wasn't that big of an issue.
Yeah.
So that little office mill, a shockingly good job. I love that thing.
Yeah. Yeah. We've got some. Yeah, we're still tooling up our Haas, and I I'm gonna get the opportunity to let it loose on some jobs coming up. So
I
I'll
can't
have
wait to
more to
see you
report
plow a
after
half
that.
inch end mill like 4 inches deep through stainless or whatever you're about to do with that thing. Yeah.
Yeah, I actually got I got some new tooling in for the machine. So one thing I didn't know, and for anyone out there who's got a new machine, find a local rep who sells Kennametal
Mm.
and talk to them, because I didn't know this, but Kennametal will give you a credit to tool up your machine whenever you buy
Oh
it,
yeah.
and it's good for 6 months after you buy your machine. And so we've been buying some Kennametal tools, and it's basically a half off whatever the MSRP on the tool is, and the dollar amount you get is based off of the cost of the machine and
Mm.
whatever they approve you for. And I don't know how they do all the ratios and stuff, but I mean, we're not probably going to use all of the coupon because we just don't have that much money laying around. But I mean, it was enough money that we can buy anything half off for that we can afford for the next 6 months, and then until it runs out. And so one of the tools we bought was an 8 flute tool for
Ooh,
stainless. It's a half
interesting.
inch. It's a half inch diameter, 8 flutes, and I think it's 2 inches or 2.5 inches long, something like that. And it's a rougher, so it's got through spindle coolant for an end mill. So I don't remember what the exact model number was, but we just got one to try it out because they said it would do really good. So I'll be curious.
That cannot be a cheap tool.
I'd have to go look it up. It wasn't cheap, but I guess I'm so used to buying Kennametal Go drills that, like, if you're used to buying Kennametal Go drills, then the price is comparable. Maybe 30% more than a Go drill of a substantial size. But that could be just because that's probably just the price with our half off right now. So yeah, that's probably a lot more expensive than
Yeah.
that normally. But I don't know. We'll see. I'm just testing out some things, trying to figure out what I like and dislike, and taking advantage of all the half off coupons I can get.
Yep.
So, but we'll see. I know that, like, the Go drills, I don't know if I've talked about it much on here, but the Go drills are probably some of the best drills I've ever used so far. And they are just they don't care about material, and they just run. I had one of them where I punched a basically a 3/8 inch hole in 1200 stainless parts, and then I got the job again for another 800, and I used the same drill. And so that one drill ended up punching about 2,000 holes in stainless, and it's still going strong. So I haven't found the end of life on it yet. The only time I've
You
ever
do
I've
talk.
ever
I was gonna say you do talk about those drills like every other episode.
Oh, I do. Okay.
I know you like
Yeah.
them. Yes.
Yeah, they've been good. So,
Harrison's Hidden Crush.
yeah. Well, I mean, when you find a tool that works well, it's just it's nice. I haven't found too
Yep,
many
it
tools
is.
like that in the end mill world. So, but to be fair, in the end mill world, the Tormach, the limiting factor was always the machine, never the tool. And so we're gonna hopefully get some better tool holders. I'd like to get some power grips and start putting all of our standard tooling in power grip holders,
Ooh,
and just see what
like
kind of tool
Rigo?
life we can get. Hmm.
Fancy.
So that's the
Expensive.
plan.
Do they give you a half
Expensive?
off coupon?
No. So I don't know when that's going to happen, but we're purposely not buying a whole bunch of ER systems, call it, or
Hmm.
ER tool holders yet. We're trying to get by with the bare bones because our plan is to go power grip at some point. At least that's our long term goal. And just because, like, I've listened to so many different podcasts and talked to a lot of other people, and a lot like I've never heard anyone say the power grip system what did poorly. The only thing
No.
I've ever heard that negative towards them is that sometimes you want a hydraulic holder for the dampening. That's like the only negative I've ever
Yeah.
heard. And even then it's just like, well, a hydraulic holder in this particular application for roughing might be better. And it's just like, okay. Sounds like the power grip's still fine though.
Yeah. The only complaint I've ever heard about them is they're expensive
Yeah. Yeah.
and higher cleaning requirements.
Yeah, that's something I need to get better at in general. I want to have a clean shop. I want to have clean tooling, clean shop, and well maintained machines, which is easier said than done.
It
So,
is.
anyways, I've been rambling for a while. What else you got?
So I went on vacation, and that was great. I'm trying to think of what was happening the week before that. I did some tiny plastic parts. There's a YouTube video up on those, and those went shockingly smoothly. I probably scrapped a couple, like getting things dialed in, but for the most part, I hit go and I got good parts. I tabbed them off so they were single ops. I had to play a little bit with speeds and feeds to take care of some burrs that were forming, but overall, they went pretty well. I also, and this was more the problem project, I did that big manifold, which I think we started talking about on the podcast, but not
I don't
like we
I
didn't
don't
hear the resolution of that.
I don't remember a manifold.
So it was just a big block of, I think it was HDPE, some plastic. And on the surface, the job looked pretty simple. But I missed a couple things when I took the job. It was a zometry job. First of all, it was just kind of larger than I was thinking it was, which is fine. Like I had the tooling to do it and everything, but lots of kind of long stick out tools. But then, so on that vein, there was a hole that goes all the way through this thing. So I needed a 6-inch hole that was, I think it was about 5/8 in diameter, maybe 3/4 inch in diameter. Which, like, I can't put a 3/4 inch drill in my office mill. Like, that's not going to happen. So I had to bore it out.
Oh man.
I ended up hitting it from both sides, and it worked really well. There was a cross hole where they met, so things could be a little bit misaligned, and you would never notice it. So that actually didn't go too bad. I did have to hand relieve that 3/8 inch diameter end mill. So I took it to my my bench grinder and put it the end mill in a drill and took off like a 1/4 inch of material above the flutes, and that did just fine. So then I started. I thought I was done with the part, and I started doing my inspection, and I found out that I missed a feature.
Oh
There
no.
was so it was like a valve manifold, right? So there was holes coming in from the side, or a hole that went all the way through from the sides, and there was like two cross holes that met. Actually, there was three, one in the middle and then two in the sides. And I missed that where the intersection is between the outer two cross holes and that middle hole, the middle hole was supposed to flare out a little bit. It was about 50 thou in diameter, larger than the cross hole. So it was an undercut, basically. And it was about 2 inches into the part. It was only like 1/2 inch deep, but it was like 2 inches in. So, and I did not have a slitting saw or anything, and I needed to ship the part. And so I was like, well, do you know what? Hand relieving an end mill worked really well with the 3/8 inch diameter one that I did on the outside. So I took one of my cheeky tool 1/4 inch single flutes that have the really stubby flute on the end. And those were pretty heavily relieved already, more than a traditional end mill. And I put that sucker in a drill and brought it to my bench grinder and ground down. I think I had to do, was it 30 thou on the diameter? Because it wasn't that much of an undercut. No, I think it was 50 thou on the diameter, 25 thou on each side. And I just ground off
Oh
50,000 from that.
my.
I killed my entire bench grinder wheel grinding the carbide, but put it in the machine and that thing ran perfectly.
Wow. That
So
that is that brings up a
it
very
worked.
interest. Yeah, that's awesome. I have had to grind several different tools, and that's one thing that I was talking to Weston about the other day was the fact that I would like to find some kind of a benchtop grinder that you can load tooling in and rotate it and shave the diameters down because I have had to do that a surprising amount.
Yeah, I think there's a variety of them. You can get like a real like tool and die grinder. You can get a fixture for a surface grinder, and I think there are machines that do that.
Yeah, and I don't need anything crazy or anything super expensive, but just the ability to rely custom relieve grind some parts or some tools, it saved my bacon so many different times, especially taps. The amount of times
Yeah,
I've had to relieve a tap, that's 90% of all the relieving I've ever had to do. Is a tap needed to go deeper. I couldn't buy one or find one that would go deep enough, and so I end up creating a longer relief behind the tap to be able to get
yeah.
down to that depth.
It's something that I've been running up against a lot lately too. With like, yes, just needing longer reach is a big one. But like the other day, I needed to put like a tiny chamfer on the bottom of an inside pocket.
Mm-hmm.
And it'd be like, I could have saved a lot of money if I just, took an old worn out end mill and, you know, quickly threw on a chamfer to the end. Or,
Mm-hmm.
yeah, it's definitely tempting, especially because I do so many weird things that need so many weird tools.
Mm-hmm. Yeah. I 9 times out of 10, I end up just chucking up a tool and a drill bit and heading over to the grinder like what you just did. So, which by the way, how'd you get a sharp edge for the top of the hole? Was that just for that tool you relieved?
So it had a chamfer on both sides
Okay,
of the relief. And so I just kind of eyeballed a 45-degree angle on it.
gotcha. Okay,
And I was taking such a small step down that it just kind of worked itself out.
gotcha. That's cool. Yeah, see, being able to like precisely add that kind of stuff, like I get a hankering for something a little more precise like that anytime I watch Adam the Machinist, because
Yeah, exactly.
he like will grind things in, and it's just like, oh, that is so nice.
Yep.
So
I've been wanting a surface grinder.
yeah,
It's far from what should be the top of my purchases right now, but I do want one.
mm-hmm. Yeah, they have their uses. We'll just become shops that have one of everything.
Yeah, exactly. Which reminds
So
me, I need to check on an auction because there's a shop closing like right down the road from me, and they have some
ooh,
stuff I need to. I bid on a couple things,
mm-hmm.
mostly like there were some toolboxes that I wanted and some stuff like that. Nothing major, but I've been meaning to call them. They have a Citizen R32 or something like that,
Mm-hmm.
and I don't think it's going to go for very much money.
Ooh,
So
that'd be cool.
it is old though,
Yeah.
so I probably shouldn't, but I kind of want to.
So wait, would that? Do you want a lathe?
I do want a lathe, definitely.
Okay.
It again, this probably should not be my first purchase, but I've been running into scenarios where I need a lathe more and more and more recently. A
Oh,
lot of the
okay.
small stuff is lathe stuff. And so something like a Swiss lathe, I think would make sense at some point. That point is probably not for like 2 years, but I don't know. If one landed in my lap, I wouldn't say no.
Yeah. Yep.
I have been sort of balancing my income streams recently, though.
Oh, that's good.
One of my goals is basically like the way I want the business to work, and there's a lot of flexibility in how it's going to be, but ideally I would like it to be like 1/3 YouTube, 1/3 job shop work and 1/3 products.
Mm-hmm.
And if it ends up like 60, 20, 20 or whatever, that's fine too. The idea is I want things to be a little bit more balanced. And lately I've been like 100% job shop, but YouTube is starting to become a useful percentage of my income. It's by
That's
no
awesome.
means a large percentage, but the most recent video I did pretty well. I actually I did make more money on the video than on the parts.
That's hilarious.
So, or at least I will once it runs for a little bit longer, I think. But that video kind of gave a boost to the rest of my channel where I'm my first goal for like this year on my YouTube channel is to get it providing $1,200 a month. And that's the magic number where it's paying my mortgage, which is about $1,200 a month.
Yep.
So that is starting to come out. And I'm starting to work on some product ideas and some product designs.
Ooh, that's exciting. Anything you want to tease or?
Yeah, so I'm working on I've already made one, a mounting plate for 3-jaw chucks or 4-jaw chucks, just like the one that I just made the other day. I'm going to have Harrison make some and sell those under the Cheeky Tool brand. And it's just a really quick, cheap, easy mounting plate to be able to put a 3-jaw chuck on the Saunders fixture plates. So that's the first thing. And then on vacation, I kind of caught the bug to work on a 0-point system. And so I have been working on a 0-point because the world needs more 0 points, obviously. But I was kind of able to flesh out the idea during vacation and over the last couple of days. But basically my goal for it is for it to be small, cheap, and low profile and lightweight. I'm not going to be aiming for the highest precision one in the world. If it's like plus or minus, I don't know, 0.3 or so, maybe 0.5 at the edge of a pallet, I think I'd be happy with that. But I think I can keep the cost like very low compared to the other systems.
Gotcha.
So
is it gonna be a quick swap system of any kind, or is it just going to be positional?
It will be quick. The one I'm designing right now is not pneumatic. It's actually going to be ring operated. Like it's going to have a ring around the outside that you can turn. So you'll either like grab that with a wrench or put a stick in it, like the Aroa. The Aroa. Do they do that?
Aroa?
Yeah, the Aroa ones. You put a stick in them and you turn it. It might be kind of like that.
Gotcha.
But my goal is to make it as few pieces as possible that are all something that can be made pretty easily on, like without needing any like high precision grinding.
Gotcha.
So right now there is one dimension that I have not been able to get away from grinding on. I think it'll probably have to be grinded. And that is like the thickness and the parallelism of the little puck. Because I haven't been able to find a way to cheat that. But everything else I think could be done on a Haas or a Tormach or whatever.
I mean, to be fair, Saunders and Pearson both do most of their products on a Haas.
It's true. But they also grind them.
They do.
So they do. I did design it so that I could use pre-ground stock that you can buy, because right now it's only a 1/2 inch thick, and it's designed to buy so you can buy pre-ground 1/2 inch stock, and I could just cut it out of there if I needed to. But honestly, I think it'll be cheaper just to have someone grind up a bunch of blanks. Though here's a question for you. So, okay, you take a part, you face it on a lathe. What kind of flatness could you, and then you part it off on the back. What kind of flatness could you expect to get across the face of that part?
Honestly, I don't like the flatness that our the surface finish that our current grooving tool does. So we always have to do an op2, and I've never checked it because it also leaves a little stud whenever you part off that has to be taken off as well. And so
the stud would be fine.
I've never checked it, and that's one of those tools I'd like to get switched out at some point because it's just the Haas groover and it does all right, but it doesn't leave a good finish if you want to have that as like a one and done part.
Yeah. You couldn't, well, you wouldn't want to do this whole thing, the whole chuck on a lathe, but I
Mm-hmm.
think you could blank out bodies on a lathe, and that might be good enough over over grinding. I'm not sure. Um,
I believe it's pretty good. It's definitely a lot more parallel than transferring it or flipping it over and then trying to keep it parallel.
yeah.
It's a lot more accurate than that. Because I have that issue sometimes where I part off parts and then I have to have a set of soft jaws that I stick a part in, and trying to keep those parallel to each other. Man, the smallest little thing gets in there, you
Yeah.
scrapping parts.
I would have
So
to imagine that there's a way to do it on a lathe because even if you didn't use a grooving tool for the whole back, the whole top and the whole bottom of the puck don't touch the surfaces. They're relieved by a cup like 10th thou or something. So it's
hmm
basically just like a half-inch outer ring. And
yeah.
so all you'd have to do is make sure that the finishes and the parallelism on that like outer half inch is good.
Oh yeah, and you could do that. So if you didn't use the part off tool, if you use the grooving tool, that leaves an awesome finish. And so what you could do is you could face the front and then face like a quarter inch on the back, and then
Mm-hmm.
use the part off tool the rest of the way. And then if you relieve pocket everything else that was on the inside, if the face off side became the bottom that would sit on something, and the top half with that quarter inch groove was the other side, and you cut out everything on the inside of that, I could see that working.
Okay.
Does that make sense?
Yeah. How does your lathe do with 3-inch stock?
2.5.
Oh, is that the max through bore?
Yep.
That's annoying.
Yep.
Yeah, even 3-inch feels kind of small for this.
Yeah. So yeah, I have a local machine shop that has a 4-inch through bore. That's the highest they go.
I mean, that's a pretty big lathe to have a
Yeah.
4-inch through bore.
Yeah. It's
Even a
their
two and a
biggest
half
one.
inches in a small lathe.
No, I wish it was 3 inch. The amount of times that I've needed it to be above, but between 3 inch and 2.5 inch is astounding. So like once you get
Hmm.
above 3 inch, then it becomes more like a part that could be held in like a 3-jaw chuck size.
Yeah.
So
Well, yeah. Could you stick like a foot of this in a 3-jaw chuck and take like 6 salami slices off the end or something?
oh yeah, yeah, you can do that.
That's kind of what I was imagining.
Yeah, you just can't through bore it, and
Yeah.
you need to catch me at a time whenever I've taken off the and switched over to the 3-jaw, taken off the Royal Collet system, because it's kind of a pain. It's like a hour or two tear down.
Oh, yeah. But
So
anyway, I've been working on the design. Right now, it could be done all in 2 ops on just about any 3-axis machine. You don't need any tolerance tighter than plus or minus 2 thou, other than the parallelism tolerance between the top and the bottom. Making the pallets again doesn't require precision tighter than plus or minus 2 thou.
yeah,
So
that'd be cool.
the last step. So basically, I figured out like positioning the palette or whatever, and the
Mm-hmm.
next step I'm working on that I have kind of a half finished model of is how to actually like retain it and hold it down and clamp it.
Mm-hmm.
Um, and I tried a number of ways that I thought were going to be simpler. Plan A was to literally just put like a male thread sticking up, like a
Mm-hmm.
big old, 3/4 inch, fine pitch thread, and have like a gear driven system to just kind of like literally tighten down and just, pull down
Mm-hmm.
the pallet. But it turns out that is far more complicated than just doing a ball joint or like a ball coupler. So I had to switch to a ball coupler.
Mm-hmm.
I did just consider sticking a nut underneath it and like retained by a ring or something, and having you put in a ratchet. But that made it too tall because I want to keep it very short.
Yeah, that retention, that is going to be a challenging thing.
My current plan is to use a 5/8 inch dowel pin and basically put just like a groove with chamfered edges. I don't know what you'd call that. Around it, just like a normal, like a pull stud. It'll look like a pull stud from a mill, and then use a ball coupler joint to suck it down.
If you're already going with a circular puck deal, and you wanted to go like 3 parts, and you have a whole assembly, basically, you'd have your top pallet, your bottom puck, and then you'd have a ring that would engage in external threads on whatever your puck was, and then you just have a bar that you rotate that, and it'll grab external threads on your puck, or on your top piece, and then your
Oh,
puck, you just design it with a lip that piece would
yeah,
sit against, and then it'll pull the two pieces together.
that could work actually. You'd have to have like 3-inch diameter threads on your pallet.
Yeah, or
That's not the
some
worst idea ever.
or some thread, like, maybe it's a ramp system or something. Maybe they're
Yeah,
not like traditional threads, but it's just something that you press up against, and then you rotate, maybe 90 degrees or 180 degrees to like basically try to mock thread it on, and then that would basically get it down to like 3 pieces.
yeah. Yeah, well, right now, in terms of machine components, I have the puck base, I have the pull stud, I have the ring that goes around the outside that triggers the ball coupling mechanism, and I have a cap that goes on the bottom.
Mm-hmm.
So 4 parts, and then there's like 3 dowel pin. Well, there's a bunch of dowel pins on the pallet, but there are like 3 dowel pins inside the puck. No, that's not true. There's 7 dowel pins inside the puck and 14 steel balls, but those are all off the shelf.
Hmm.
The pallet, all you need to do for the pallet is put a threaded hole in there and a bunch of dowel pins. The way the system works, I don't think I've ever spelled this out either to you or to the audience, but basically, I am finding cheap precision through elastic averaging. That's the trick behind my 0 point. So the pallet has a whole bunch of pins. The receiver, the 0 point system, has a whole bunch of flexures that receive those pins, and each of those flexures gets you plus or minus 2 thou of slop. So if your holes for where you drilled them and put your pins, those can be a little bit off, but the all the flexures will fight and find the center. And the idea is the errors should average out to give you a repeatable position with different pallets.
So I'm going to ask you a question that a potential customer might ask. Because you're using flexures to locate it, what will it do if I put a large side load on it?
So it's the flexures are centering it, and then you bolt that sucker down with you hold it down against a flat surface, and the friction prevents the side load
Okay.
from.
Okay. So you're
I would also
relying.
say
Go ahead.
I would not put this thing on a Hermle taking a 1-inch end mill. Like this is for light machining.
Okay. Okay.
But yes, I would say this is more for Tormax and office mills, that kind of thing. You
Gotcha.
can put them on bigger machines, but these are relatively small.
They're not necessarily for small machines, but they're for small parts.
Yeah, they'll get you pretty good precision. They'll get you pretty good work holding at a really good price.
Gotcha.
That's the goal.
Yeah.
Basically, I'm making what I wanted the flux puck, or what I wanted Saunders' flux puck to be. Flux puck? No, that's flux work holdings. Chuck puck. I'm making what I wanted the Chuck puck to be.
You're gonna have the Chuck flux puck.
Yeah.
That's funny.
I don't have a name for it yet. It could be like the flex puck. Just to confuse people more. So,
Yeah.
I don't know if this is going to go anywhere, by the way. I did order some aluminum to prototype it in. McMaster sells 1/2 inch, 3-inch discs. So I got like 2 of those with my most recent McMaster order.
Gotcha. I
And
wish you the
I don't
best
know.
of
We'll
luck
see
for
if it
that.
works. It would be
Because
nice if it became a third of my business.
it's an interesting idea. That is for sure. I would be curious how it actually works in execution.
Yeah. And it should be fairly easy to make. It's got some like funky features. Like if
Mm-hmm.
you look at the flexures, they kind of just look like holes with some slots next to them.
Mm-hmm.
But there's some kind of weird geometry on the inside of the hole,
Mm-hmm.
and there is an undercut to kind of separate the wall of the flexure from the bottom so that it has room to flexure.
Oh, okay.
So, but I don't know. It's stuff that some people would look at as complicated, but it's the kind of stuff that I do all the time. So I think it'll be all right.
Is the way that they're all positioned, are they all going to be in tension? Like, is it slightly undersized for the pins?
Yes. Yeah. So
Okay.
the relaxed state of the flexure is 2 thou under 3/16 of an inch. I'm using 3/16 inch dowels to
Okay.
locate it. So there it's 0.185 or whatever the whole size would be. And I don't know right now how big they could flex up to, but they should get at least 2 thou flex in the other direction.
Gotcha.
Probably more.
Fair enough.
So I don't know. Some testing necessary. If the design works really well, then I'll make it a product. If the design works kind of well, then I'll open source it. And if it doesn't work, then we'll just forget that it ever happened.
Yeah. The forgotten puck.
Yeah. But you don't know until you try it.
Yeah. No, that's good. That is good. I don't think I got anything else yet right now.
We should do administrative details. So we are a podcast. We are also do YouTube. If you are watch YouTube, then you can go listen in a podcast player. If you're listening in a podcast player, you can go watch on YouTube. We also have a Patreon, and huge shout out to our Patreons. We have EJ from Nocturnal Welding, Simon Thought Bomb Design. I think I was supposed to call Thought Bomb Design a different name, and Jake Brownson. I'm sorry, we have Chris from Thought Bomb Design. Sorry, Chris, that's how I'm supposed to address you. And we have a new Patreon, which is Faro Technologies LLC. And they did offer to do some SLS 3D printing for us if we ever needed it, by the way.
Ooh.
And they make the Pew Pew related accessories. So farotech.com if anybody wants to check them out. And they are also our small business shout out, which you do not have to be a Patreon for, but it is welcome. If you would like a shout out, just shoot me or Harrison a message and we will give you a shout out. But Ferrotech, they look like like I said, they do some Pew Pew accessories. They have some accessories for, looks like locks, some Chris Vector stuff, some Keltec.
I really wish I had known about them sooner, because I had been doing a whole bunch of SLS 3D printing recently, and I'm not doing any more for a while. But I was searching so hard for companies with SLS printers that I could find, and the one I ended up going with, I mean, they did a good job, but they messed up one of my colors. It was supposed
Oh
to be
no.
it was supposed to be an all white order, and they had one that was black. So
they have a cool little mount to put a red dot on a Ruger 1022, and I kind of want one.
I have like 4 Ruger 1022s now.
Would you like a red dot sight mount for it?
They're so much fun. I might. My dad just got another one. I think he got a one of those takedown 1022s that you can split them in half.
That's cool.
They're really cool.
I need a little something like a 1022 to drive off the occasional coyote or whatever in our backyard.
Man, as a kid, I used to go through like a box of like 500 rounds, like a
It's
month.
easy on a 22.
I know. I used to have so much fun. Now they're so expensive.
Yeah.
22 ammo. That is. Used to be you could get a box of 500 for like $10.
I have no idea what the prices are anymore.
More than that.
Okay.
Although I haven't looked in a hot minute. And that's it. We're getting sidetracked. So thank you guys for hanging out with us for the last, I don't know, it would be a little over an hour. So this has been Harrison with Precision Ingenuity, signing out with AJ from Audacity Micro. When I'm tired like this, I'm going to call you Design the Everything one of these times. Because that's what I'm so used to saying. But anyways, for those of you who have been listening to us, we appreciate it. Please like, share, and tell all your friends. And we appreciate all the new listeners that we've been getting and the new Patreon supporters. That's been awesome on both fronts. So thank you guys. And one more thing, we still need to get these guys coins. So we need to figure that out.
Yes. I asked my brother to do a design for us.
Okay.
So
we're working on the coins. We'll get them. So anyways, that's all it.
A Ruger 1022 is $320 in case anyone was wondering.